Welcome back, Apologia, 8th grade physical science, week 22, day 2, textbook pages 371 through 377, notebook pages 310 through 312. The start of this day is experiment 10.3, the refraction of light, the purpose of which is to explore what happens when light encounters a transparent obstacle. We will be doing that in class. So, let's just jump to the text. What did you see in this experiment? First, you should have seen that when the light beam hit the pan, part of it was reflected and part was refracted. This is what happens most of the time when light waves hit a transparent obstacle. Part of the wave will be reflected and part of it will be refracted. There are certain circumstances where this does not happen, but they are rare. Had you measured the angle of the reflected ray, you would have determined, as you did in the previous experiment, that the angle of refraction equals the angle of incidence. Have you ever looked through a window and saw your own reflection? The reason you can look through the window into the outside world is because the window is transparent and light can pass through it. That's also why you can see the lights of a house through its windows. However, not all the light from the house makes it through the window. When a wave encounters an obstacle, a portion of the wave is always reflected. The reflection you see in a window is a result of the portion of light waves that is reflected off of the glass instead of transmitted through it, as in figure 10.28. What did you notice about the light ray that entered the water in the experiment? The fact that the water was cloudy allowed you to see the ray as it traveled through the water. You should have noticed that the light beam coming from the flashlight did not follow the line you had aimed it along once it entered the water. Instead, the light beam followed a path that was somewhere between the line you had aimed it along and the line that was perpendicular to the edge of the pan. In other words, when the light ray entered the water, it was bent toward the line that was perpendicular to the surface the light ray hit. What happened when the light ray hit another side of the pan? You should have once again seen that part of the light was reflected back into the water and part of the light refracted as it entered the air. The fact that light rays bend when they are refracted is a general rule of physics. In fact, the rule is even a bit more detailed than that. In general, we can say that if you draw a line perpendicular to the surface the light ray strikes, refracted light will bend toward that perpendicular line if light travels slower in the new substance than in the old substance. If, on the other hand, light travels faster in the new substance than in the old substance, the light ray will bend away from the perpendicular line. When light refracts into a substance in which it must slow down, the light ray will bend toward a perpendicular line to the surface it strikes. When light refracts into a substance in which it speeds up, the light ray will bend away from a line perpendicular to the surface it strikes. These two general rules can be summed up by figure 29. So figure 29, let's assume that light is completely transmitted through the glass beaker, traveling at the same speed as in the air. When light strikes the surface of the water, part of the light is reflected and part is refracted. The part that is refracted bends toward the perpendicular line, which is the black dotted line. So here we have the perpendicular line. This part of the line bends toward the perpendicular line because light travels slower in water than in air. When light strikes the surface of the glass again, part of the light is reflected. So we have part of the light reflected and part of the light is refracted. The refracted ray bends away from the perpendicular line because light travels faster in air than in water. The refraction of light through different substances is responsible for all sorts of optical illusions. Have you ever been traveling along a road on a hot summer day and noticed what appears to be a puddle of water in the middle of the road in front of you? When you got nearer to where you saw the puddle, it vanished. That puddle of water is an optical illusion that is the result of the refraction of light rays. When a road gets hot, a layer of warm air rests right above the road. When light from the sky encounters this layer of hot air, a portion of the light refracts. Rather than striking the road, it is bent into your eyes. Thus, you see a fuzzy image of the sky. Since the sky is blue, you think you are seeing a puddle of water. Instead, you are simply seeing light that comes from the sky and is refracted through the warm air to your eye. This kind of optical illusion is often called a mirage. People traveling through hot deserts are prone to seeing such illustrations. All right, next up we have the You Do Science, the Magical Quarter. We will do that in class as well. Before we leave refraction, I need to point out two things. First, when light encounters a medium, refraction does not always occur. Depending on the substance, there are certain angles of incidence that lead only to reflection, not refraction. Although the situation is rare, it can be very useful. Fiber optic cables, for example, transport light over great distances because when light enters the cable, it cannot escape. When it hits the edges of the cable, there is little or no refraction. There's only reflection. As a result, even a tiny amount of light can travel a great distance down such a cable. The second thing I want to point out is that refraction depends in part on the wavelength of the light involved. That's why you were able to separate light into its different colors in experiment 10.1. That's also why we see rainbows. When there are many water droplets in the air, and when the sun shines on those water droplets, the refraction of the light through those water droplets forms beautiful rainbows.